We are now going to write matrix equations. We're going to write them. And I'm going to use this example here in just a minute, but first some boring algebra. Let's look at if I had a matrix known as capital, let's see if I'm on the right, there we go. If I had a matrix which was capital A, like that, and I multiplied it by another matrix called X, some unknown matrix, well then it would equal some other matrix B. Much like, I'm going to relate this to regular numbers, much like the way that 3 times x equals 15. Now, if I ask you, what does x equal, you would say 5, right? Everybody knows that. You divide both sides by 3. But we can't do that over here. And not only to mention that, don't write this, so I'm going to delete this. This would be the standard textbook way of solving that. We've done that a million times in here. When you divide by 3, what actually is going on, though, what actually happens is you are multiplying both sides by 1/3. And if that's blowing your mind right now, it's true. Dividing by 3 is the same as multiplying by 1/3. I'll prove it. 15 over 1 times 1/3 should equal 5. And I think what makes that confusing is some people are a little weak and deficient in the area of fractions. Okay? So multiplying by 1/3 and dividing by 3 are the same thing. Now, let me get rid of that. Instead of 1/3, though, we could take this to another level and do what we did yesterday, which was this. That is also true. Yesterday we looked at a problem that said 7 times 7 to the negative 1, or maybe it was 6. I'm not sure what the number was. But we said that equals 1, and that's true. That's the reciprocal. Well, you wouldn't really do this in algebra class, but over here when you talk matrices, that's exactly what you do. You multiply. If I want to solve this for x, you have to do the inverse of a to both sides. That's just the way you have to do it, because the inverse of a times a equals the identity matrix. That's what the questions we were talking about today, the identity matrix. So the identity matrix is 1, so we would have x on this side equals b times the inverse of a. Now if I flip-flop this around, a to the negative 1 times b, this is usually the standard way that that's written. A to the negative 1 times b. So I want you to plaster your notebooks with that and put big stars beside it so that you can find it easily, because that's how we're going to do it on the calculator when we get to this. Today, though, what I want to show you is how to write matrix equations. All right? How to write a matrix equation. Let me show you this. Fantastic. Here is a typical little simultaneous equation problem. We could do elimination on it and solve that easily. Well, I'm going to show you another alternative way of doing this that I think you'll like way better than that. I can make matrices around this, and then I'm going to strip off. Now, this only works if you have the x's lined up, the y's, and the numbers. I'm going to take out the x's and y's now, just leaving the numbers, the coefficients. This would be 5. What would go right here? Negative 1, because that's negative 1y right there. Here would be 2, and this would be 3. Now, when you write this, I want you to skip a little bit of space here. I want you to exaggerate that, because I'm going to put something right there. Over here, that's going to be 16 and 3. Okay? Now, when you write a matrix equation, we need to put this X matrix in here, this X matrix right there, this variable matrix, if you will. And that is, of course, X and Y. So now I want you to think about this. If this is correct, then this matrix equation here, this is called a matrix equation, equals this regular old equation. So let me just show you how that works. If I were to take the dimensions of this, this is a 2 by 2. What size is this yellow one here? That's a 2 by 1. Can I multiply that? Absolutely. The inner dimensions match. My outside answer would be a 2 by 1 if I did that. Let me show you. If I did this row times this column, I would get 5 times x plus negative 1 times y, which is negative y. Isn't this the same thing as that? It most certainly is. And if I do the bottom row times this, it would be 2 times x plus 3 times y. 2 times x, 3 times y. And so I would get this matrix like this, and that would equal 16 and 3 over here. So you can now see clearly that this is the same as this. They're the same thing. So that's how you translate that into a matrix equation. Now, when you go to solve this on a TI-84 or something like that, you're going to have to fall back to this equation, but I'll show you how to program that in class, and have a good day.